Hello, welcome to our next statistics video. This one is about binomial distribution. A binomial experiment is an experiment or process or survey or whatever that has two outcomes, a success and a failure. The experiment is done for a specific amount of trials. So maybe you're doing a survey and you're picking 5 random participants, or perhaps you are flipping a coin a specific number of times. The probability of success, which is a lot of times called P of S, does not change from trial to trial. So if you were in a situation where you were drawing a card out of a deck and not putting the card back, that would not qualify as a binomial experiment, because by taking the card out, you would be changing the probability for the next card you draw. The probability of failure is always going to be 1 minus the probability of success, because since you only have two outcomes, P of S and P of F always have to equal 1. And sometimes P of F, to simplify things, is just called Q. And sometimes P of S is just called P. You'll see those terms used interchangeably. The random variable X represents the number of successes over in trials. So if you were drawing cards out of a deck and putting the cards back, and you were trying to get a 2, maybe you get 1 2s or 3 2s or 4 2s or whatever, that would be your success value. So here's an example of a binomial experiment. It says, in a recent poll, 35% of teenagers exercise regularly. 5 teenagers are chosen at random. The random variable X represents the number of teenagers who said yes. So right now, your P of S, your probability of success, is 35%, because 35% say they exercise. Which means your P of F would be 1 minus 0.35, which is 0.65. And then we're calling a success someone who says, yes, I exercise. And a failure would be someone who says no. So since we are sampling 5 teenagers, 5 people from the total study, we could grab 0 people who say yes, 1 person who says yes, 2, 3, 4, or 5. So these are our possible outcomes. You could have 1 person who says yes, or all 5 people could say yes. It just depends. And that's what we're going to be calculating the probability for eventually. Now, the problem is, to do this by hand is very complicated and often involves making a tree diagram. So we have a formula, and the formula actually coincides very well with your binomial expansion theorem. It uses a combination, your n choose R, where n represents your number of trials, R represents your number of successes, and then P is your probability of success, and Q is your probability of failure. And you'll notice we have some powers. And the powers correspond to the number here. So X is technically your R value, and N is your total number of trials again. So X is your R. Your number of successes. All right, so let's try to apply this formula. And a lot of times it's just easier when we use numbers to construct a table and then a graph of the probability distribution. So this is the information from the problem above. The probability of success, or just P, is 0.35. And the probability of failure, which is Q, is 0.65. So I like to make a table because I feel like it's nice and organized. So X is your random variable. So 0 people could say yes, 1 person could say yes, 2 people, 3 people, 4, or 5. So the probability that 0 people say yes. So out of the 5 people, we have 0 successes. We multiply that by 0.35 to the 0 power, because that's my successes, times 0.65 and my number of failures, which in this case would be 5. Again, the formula is kind of complicated, but a lot of times it's just easier to do it with some numbers. And then go to your calculator. You can actually punch this in exactly how you see it. To make your calculator operate the combinations for you, hit the math button, and then scoot on over to probability, P-R-O-B, and you'll see NCR, option 3. Now, depending on your version of your calculator, mine pops up little things to fill in. If you have an older version, you might have to type the 5 first before you bring up the N choose R. So 5 choose 0. And then 0.35 to the 0 power we know is 1. So that we don't really have to punch that in. Times 0.65 to the 5th power. And this will be a decimal, and we will just round to 3 decimal places. Make sure you're always following directions when it tells you how to round. Sometimes it'll say 3, sometimes it'll say 4. So then you just repeat the process. And I'll go ahead and write it all out. So if I have 1 success, that means my success probability has 1. And that means my failure probability has 4. If I have 2 successes, that means 2 people out of the people I poll say yes. So notice both of these are still always adding up to 5. 2 successes, 3 failures. 5 choose. And then if I have 4 successes, we have 0.35 to the 4th, and then 0.65 to the 1st. And then the probability that all 5 of them are successful, 0.35 to the 4th, and then 0.65 to the 0. And we'll punch in one more together. So again, you're hitting your math menu, you're going over to probability. Option 3 is NCR. I'm doing 5, choose 1. Make sure you arrow out at the bottom. Times 0.35 to the 1st. So you really didn't need the power there. Times 0.65 to the 4th. And you get 3.12. And I actually have all of these figured out, so you don't need to watch me punch them all in. So we have this, and then if we wanted to construct a table to kind of see how it was distributed, we can certainly do that. So you would have 0. This is probably going to be more of a bar graph. 2, 3, 4, 5. And then all of these are less than 1. These do add up to be 0.999, which is close enough to 1. So we'll say that and then 1. So 0.166, that's just under 2. Then 0.3, just over 0.3. And 2, we're almost at 2, not quite though. And then at 3, oh wait, sorry, I read the wrong one. At 2, we're at 0.336. Right there. And then at 3, we're at almost 2. And 4, we're pretty small. That's our smallest that's one of our smaller probabilities. And then 5, that's like the little guy right there. So there's your probability distribution. It's a little skewed. And then I could ask you to do lots of different things. So I could say, what is the probability that you pick 3 people who say yes? And that would just be 0.818. What's the probability that x is greater than 3? Or equal to 3, sorry. So the probability that x is greater than or equal to 3, so that means 3 people say yes, 4 people say yes, or even 5 people say yes. What's the probability that any of those things happen? You just add them up. So it would be 0.181 plus 0.049 plus 0.00. And when you add up those 3 things, you get 0.235, which is like 23.5% if you wanted to express it that way. And there are lots of different combinations that I could ask you, like what's the probability that x is less than 2? Notice not equal to, so less than 2. So what's the probability of getting a 1 or a 0? Or the probability of getting a 1? Not a 2 because it's not saying including 2. So you would say 0.116 plus 0.312. Or 42.8%. And that's all we have for today. If you have any questions, please feel free to contact me. And as always, make good choices.